Okay guys, so now we start diving into imaginary numbers. So the first thing that you can see is what the definition of an imaginary number is. Like we talked about in class, when you square root a negative, which up until today we couldn't do, square rooting a negative is the equivalent to square rooting -1 equals I. So if I was to do I squared, that would be like -1 inside the square root times -1 inside the square root, okay? And basically that's the same thing as the square root of -1 squared. And like you guys should know by now, when you square root and square something, those two things cancel each other out, leaving you with just what's inside. So that's why we have this little nugget of information that I squared equals -1. Okay, so a complex number, we know what an imaginary number is. A complex number is a number that has a real part and an imaginary part. So as you can see from this little thing right here, you have the real part would be the A and the BI is the imaginary part. This is super easy. Do not overcomplicate this. Okay, so when you look at these examples, the 3 on the first one is the real part, -2 is the imaginary part. The 0 is the real part, the 4 is the imaginary part. 2/3 is the real part, 1/2 is the imaginary part. -60 is real, and 30 is the imaginary part. A and B can be any real number. They can be positive, they can be negative, they can be irrational, rational, or 0. So for instance, like this one right here in the middle, you probably would only see it written as 4i, but that is complex because there's an invisible 0 in the front. Okay, adding, subtracting, these things are pieces of cake. Basically, you add the real parts together, you add the imaginary parts together. So for the first one, I'm going to add, since this is addition, I'm going to do 3 plus -4, and I get -1. And then I'm going to add my 2i plus 6i, and I get 8i. So my answer to this one would be -1 plus 8i. Okay? We'll do one more practice together, then you guys can hit pause and do the other one. Okay, for this one, I'm going to have my 9 plus -3, so that gives me 6. And then I'm going to add my 2i plus 5i, and I get 7i. Okay, hit pause and do the next one by yourself. Okay, if you hit pause, you should have, now can check your answer. 1 plus 11 gives you 12, plus -3i plus 4i gives you 1i, or just I. Subtracting is very similar. The one thing that you do have to make sure of is that you distribute that negative to change the sign. So this is going to be -1 minus 7i. And then I can add my 2 plus 5i onto that. So my final answer to this one, 2 minus 1 gives me 1 for my real part. 5i minus 7i gives me -2i. Okay, some people just go piece by piece and they would say, like for instance on this next one, they would say 9 minus -3. 9 minus -3 would be 9 plus 3, and then they would do 2i minus 5i, and that would give them -3i. Okay, so you have to choose. Do you want to distribute your negative, or do you just want to treat each part individually? Okay, hit pause and do the next one, and then check your answer. So your answer to this one should be -10 minus 7i. All right. Last but not least, we have multiplication. And when you multiply, you're going to be foiling or doing that first, outside, inside, last. Some people like to set this up with a box method, so I'll show you one of each way, and you can choose which one you like to do the most. But the one thing that you have to remember is to simplify this. This is super important, that I squared equals -1. So you're going to have to remember that when it comes to simplifying. Okay, so the first one I'm going to just do with distributing instead. Okay, so when I distribute this 4, I get 4 times -2, and I get -8. When I distribute the 4 to the second part, I get +12i. And then we have to distribute this I, and that gives me I times negative 2 gives me negative 2I. And then I times positive 3I gives me positive 3I squared. So there's the thing that you have to remember to fix right here. Okay, so when I see that I have an I squared, I'm going to go back here and I'm going to change. This becomes a negative 1. Okay, so you basically have 3 times negative 1. So the easiest thing to think is that it's going to change the sign of whatever you have. Okay, so if we clean this up a bit, we're going to get negative 8 plus 12i minus 2i gives me plus 10i. This now just became minus 3. So all in all, my answer is going to be negative 11 plus 10i. Okay, kind of like combining like terms. We're going to make sure that you finish it up and have a final answer. All right, the next one I'm going to do is the box method, so you can choose which one you like the most. Okay, since this is 2 parts by 2 parts, I'm going to build a 2 by 2 box. So I have my 9 plus 2i on one side, one horizontally and one vertically, and then my negative 3 plus 5i on the other one. Doesn't matter if you put the negative 3 plus 5i going down the side and you flip-flop these. Okay, so in this box, kind of like Punnett squares, we've done this before, you get negative 27. Here you get 45i. So this is just helping me organize my distributing from before. This gives me negative 6i, and this gives me 10i squared. So squared is going to change this to negative 10 because it was positive 10i squared. Okay, now I can write my final answer and combine all my like terms. So I have negative 27 minus 10 gives me negative 37. 45i minus 6i gives me positive 39i, and that would be my final answer. So I have my real part and I have my complex part. Okay, hit pause, choose your method, and do the next one however you see fit, and then check your answer. Okay, so either way that you do it, I showed you both ways, depending on which strategy you like the best. You should get 120 because that became positive 60 when you changed it from negative 60i squared. And then when you combine negative 100i plus 36i, you get negative 64i. Okay, the last couple problems are multi-step. They have like, first you have to FOIL, then you have to combine like terms. So like on this one, the first thing I'm going to do, and I'm just going to just do distribution. So I'm going to have to FOIL these two. So when I multiply this, I get 15 minus 5i. For the 2i, I get 6i, and then negative 2i squared. So I'm going to go ahead and change that to plus 2 instead of minus 2i squared. And then I still have this plus 7 minus 4i. So I basically have a lot of combining like terms to do. Okay, so now I have 15 plus 2 gives me 17 plus 7 gives me 24. Negative 5 plus 6 gives me positive 1. Minus 4 gives me negative 3i. Okay, so basically I just went through and I combined all my like terms. So these guys all went together. 15, 2, and 7 gives you 24. Negative 5, positive 6 gives you positive 1, minus 4 gives you negative 3. So there's your final answer. Okay, one more. You guys go ahead and try to do this on your own. Now remember, this first part right here is 6 minus I squared. So you basically have 2 multiplications to do. So you might be better off considering writing this out as 2 binomials before you get started, and then do your distributing. My problem's like magically moving. Okay, so hit pause, finish this off, unpause it, and check your answer. Okay, so here's your final answer, guys. So check all the work, go through, and 42 minus 3i is your final answer. So that should be it.